For this section of the lesson, we have, in this example, log base 3 of 2x equal log base 3 of 4 plus log base 3 of x minus 5. Now, before we can do any solving whatsoever, and for a log equation, we have to follow the property of one-to-one log equation, which is here, log base b of x equals log base b of y. If you take a closer look, you see that there's only one log on the left side and one log on the right side. If we take a look, here's the left side, we do have one log, but on the right side, we have two logs. And if we take a closer look, they all have the same base. So before we could actually do some log equation solving, we have to make sure that we have to get one log on the left side and one log on the right side. So how can we combine these two logs as a single log? By using one of these three properties: the product property, the quotient property, or the power property. So on my left side, we only have one log, so that's okay. So I'm going to bring that one down. Log base 3 of 2x equal. Now, let's take a closer look at these two. They both have the same base, so we can apply one of these three properties. And they have a plus. So there is a plus between these two logs. So the only property that has a plus sign is the product property. So what we're going to do, when we're combining the two logs as one, log of base 3, and then I'm going to use a bracket because we're going to combine two set of parentheses together. So what we're going to do for the product property is we're going to combine the 4 and the x minus 5 by multiplying to each other. So 4 times x minus 5. And again, I'm using brackets so that it's easy to see what I'm doing. So again, the product property, when I'm combining two logs as one, I multiply what's inside the parentheses. So 4 times x minus 5. So again, I'm not doing anything to the left side, so I'm bringing it down. Then I'm bringing down the log. And again, I'm multiplying only inside the log. So 4 times x minus 5, distributing the 4, so 4 times x is just 4x. And then 4 times minus 5 is minus 20. There we go. Now, if we take another look, yes, we have one log on the left, one log on the right, and they both have the same base. In that event, we can use the one-to-one property where we set what's inside the log on the left side equal to what we have inside the log from the right side. So we have 2x equals 4x minus 20. So I want to have my x on the left side, so I want to get rid of 4x. So my 4x cancels out on the right side, so I'm left with negative 20. And then on my left side, 2x minus 4x is negative 2x. Now we have negative 2x equals negative 20, and I want to get x by itself, so I'm going to divide by negative 2. So doing so, I get here, negative 2x divided by negative 2 is just x. Negative 20 divided by negative 2 is 10. So x equals 10. Now when it comes to log equation, we always have to check our answer, just in case if it actually is a defined solution, or if it doesn't work, then it's undefined, meaning no solution. So what I'm going to do is I'm going to plug 10 into each of the x within the original problem. So again, I'm just testing it out. Use Alright. So log base 3 of 2x, so 2 times 10 equal log base 3 of 4 plus log base 3 of 10 minus 5. Alright, so let's take a look on the left side. So log base 3, 2 times 10 is 20, equal, I can't do anything to the log base 3 of 4, but let's check on the other one. Log base 3 of 10 minus 5. 10 minus 5 is just simply 5. Now, is log base 3 of 20 equal to log base 3 of 4 plus log base 3 of 5? Is that true? So again, since we have multiple logs, it is the same as applying the product property we combine as one single log. So log base 3 of 20, and then I'm combining these two logs as one again. Doing so, I'm multiplying the 4 and the 5. So 4 times 5 is 20. And if I take a look, there's 20 on the left side, there's 20 on the right side, same base. So it is true. Therefore, x equals 10 is a defined solution, meaning that it does work. So again, x equals 10 works and is also known as a defined solution. In this next example, we have natural log of x, ln, natural log of x equal natural log of 2x plus 7 minus natural log of 3. Now over here, log base b of x equals log base b of y, the one-to-one property, can still apply to natural log. So natural log of x equal natural log of y. So we can still work with this as a log equation, but in terms of natural log, ln. So if we take a look at the left side, we have one natural log, which is good, following the one-to-one property. Now, but on the right side, we have two separate natural log. And of course, natural log, each natural log has the same base. They all have the base of e, as shown in the previous example and the one-to-one property. So, just like in the last example, if I were to combine as a single natural log, I would have to use one of these three properties. So, let's move down the left side because it's already a single log, natural log. Now if I want to combine as a single natural log on the right side, I would again use one of these three properties. So I'm looking at the operation between these two natural log, which is minus. So the only property that involves minus is the quotient property. So what's going to happen is it's going to be a fraction inside a parenthesis. So what comes first on my right side is the numerator. So 2x plus 7. And then what comes second is the denominator. So 3. Alright. Now taking a look, we have one natural log on the left, we have one natural log on the right. So since they're both, again, same base of e, then that means that we can set what's inside the natural log equal to each other. So x equal 2x plus 7 over 3. So looking at this, we have a fraction. So if I want to get rid of the denominator where it's not a fraction anymore, I'm going to multiply this side by 3. And if I do it on the right side, I got to do it on the left side. So doing that, on my left side it would be 3x, and on my right side, 3 divided by 3 is 1, and then 1 times the numerator is just 2x plus 7. So again, 3 divided by 3 is 1. Then what I get from here, 1 times the numerator is just 2x plus 7, right there. Now, we have 3x equals 2x plus 7. And say I want to have all my x's on the left side. So on the right, I have to get rid of 2x. The opposite of 2x is negative 2x. So I'm subtracting by 2x on the right side. I have to do the same thing on the left side. So my x's cancel out on the right, and I'm left with a positive 7. And then on my left side, it's 3x minus 2x, which is just x. So our answer is x equal 7. Now again, when it comes with log and natural log, we have to check our answer. Alright, so we're going to plug 7 into each of the x of the original problem. So plugging 7 into this x, so it's going to be natural log of 7. And then on the right side, it's going to be natural log of 2 times 7 plus 7. And then minus natural log of 3. So when we check in, we have to make sure that what's inside the parenthesis is positive and not 0. So on my left is natural log of 7, so that's okay. I'm going to bring that one down. And then starting with the right side, natural log of 2 times 7 plus 7. So according to PEMDAS, I'm going to work with multiplication. 2 times 7 is 14. And then 14 plus 7 is 21. So it's going to be natural log of 21 minus natural log of 3. So again, the numbers inside the parentheses are still good. They are more than 0. So we don't have to worry about any no solution. Now to check if they're equal to each other, since again we have two separate natural log, we can apply the quotient property because it's minus to combine as 1. So what comes first is 21 as the numerator, and what comes second is the denominator. So now we got a single natural log on the right side. Bring down the left side, and then here work out what's on the inside. So 21 divided by 3 is 7. So we take a look, natural log of 7 on the left, natural log of 7 on the right. That's true. They're the same on both sides. So therefore, x equals 7 is a solution, a defined solution. And it works.